Here we see a ball at the top. It will slide or roll down this inclined plane, shoot off, and it looks like it lands there. So we can see that we have changes in height and changes in velocity going on. So this is most likely a conservation of energy question. So we're told cylinder at rest at the top. It's 1 meter high. It rolls down the ramp without slipping. So we know it rolls. So there's going to be kinetic energy of rotation. At the bottom, it makes a smooth transition and shoots off like so. And lands at 1.5 meters. After it leaves the table and before it lands, so that means here, in that path in the red, how do the rotational kinetic energy and translational kinetic energy of the cylinder change? Well, let's first focus on the rotational kinetic energy. Rotational kinetic energy is 1/2 I omega squared. The question then is, what happens to the rotational velocity? The moment of inertia is fixed for the object, so it comes down to what happens to the rotational kinetic energy. The rotational velocity. Now, the reason the rotational velocity is increasing as it goes down the inclined plane is because the force of friction is providing a torque. It is creating a torque perpendicular to it. But once it leaves, there is no torque acting on it. So we would expect it to be a constant omega. So we would expect the rotational kinetic energy to remain the same. So increases would be out, and now we've got remains the same. What about the translational kinetic energy? Well, whatever translational kinetic energy it has at this location, we don't expect it to gain any more kinetic energy of translation because it's traveling horizontally. It's not picking up any energy from anything. Not only is the translational kinetic energy the same, we expect the rotational kinetic energy to stay the same. But then what happens as it moves along like so is its horizontal velocity, Vx, remains constant, but the Vz increases such that it is traveling faster translationally upon impact. Just as if it were dropped, it's going to get faster because gravitational potential energy is converted to kinetic energy. So the translational increases. Choice C.